Yesterday's lesson was a very important one. It was called the area of regular polygons. So you had a homework last night and you have a homework tonight. Both homeworks are very, very important to complete. So we're going to do this warm-up. We're going to check our homework answers. I'll work some problems, and then we'll take our quiz. But you need to make sure to devote time to practicing this, because this is one of those shapes that is new to you. You did not learn how to find the area of a regular polygon in elementary school. Now, was hexagon one of the special cases? Yes. Remember, our special cases were equilateral triangle, square, and regular hexagon, okay? So since it was a special case, we did not have to use trig. The radius is 10, so we would mark this segment as 10. Make sure you keep track of what your radius is versus your apothem. And now we're going to label our angles. In a hexagon, the 60 goes there, there's our 90, and there's our 30. That angle is the larger angle, so the 60 goes there. 10 is across from 90, so that's our 2x. So our x is 5, and our x root 3 is 5 root 3. Apothem times perimeter divided by 2. The apothem is 5 root 3. The perimeter is, let's see, how long is one of the sides? Because it's not 5. One of the sides is 10. There are 6 sides, so apothem times perimeter divided by 2. Just a side note, not that you have to know this, did you notice in a regular hexagon that the radius is always equal to the side? Did you notice that? Victor said it before I said it. Good job. So, you know why that is? Come on, we know why, right? Because if I draw this and this, 10 and 10, 60, 60, 60, so this is 10, it makes an equilateral triangle. Do you see that? So the radius is always congruent to the side, but that only happens in a hexagon. Only happens in a hexagon. Okay, let's say the answer. 150 root 3 centimeters squared. Sorry, there's lagging. So just some reminders from yesterday. Special cases, not special cases. We have pentagon, we have 7 sides, heptagon or septagon. We have octagon, we have decagon. Those you have to use trig. The special cases you use your shortcuts, and the not special cases you use trig. Now, I showed you one way yesterday to find a missing angle. I want to show you another way that I actually like better, but I didn't want to overwhelm you yesterday with too many things. Okay, so strategy number 1 is what we did yesterday. You find the angle of the polygon, n minus 2 times 180. You divide by the number of sides, and then you have to bisect it. You have to divide by 2. But there's another way to find one of the angles of that triangle to be able to use trig. So let me show you this way. If you travel in a full circle, you travel 360 degrees. Now think about if I were to draw triangles all over this, right? I would have, what is this? 1, 2, 3, 7. I would have 7 triangles. And then I would need to cut it in half. So I could literally just take 360 and divide it by the number of sides doubled, and that would give me that angle up top instead of the angle at the bottom. So 360 divided by 14, 25.7. So this angle is 25.7. That's messy, but you get the idea. So you can do n minus 2 times 180 divided by n and then bisect it, or you can just do 360 divided by the number of sides doubled. Why do we need an angle? We need an angle so that we can do trig. Okay? Let me show the answers to the homework, and then as I'm working one of the homework problems, make sure to ask about one where you had to use trig, and I'll show you the 2 ways when we actually solve a problem.